Hello everyone, welcome to the Education for Next Generation. I am Sravanti introducing you to the class of chemistry and the topic is chemical reactions and equations. We know we all are very much familiar with the reactions or the changes which are taking place in our day-to-day life, like the growth of a plant or a tree, or the curdling of a milk, or sunrise and sunset. All these changes which are taking place around, these are categorized into two types. One is a physical change and a chemical change. The changes which are observed in our day-to-day life are of two types. One is a physical change and the other one is a chemical change. Now, in terms of chemistry, we consider these changes as the reactions. The physical changes like sunrise is again getting converted to sunset, or summer season is getting converted to winter season or rainy season. Now, the chemical change, if I take the hydrogen when reacts with oxygen, the two gases when they react with each other, it gets converted in the form of water. Now here a new component is formed from two different components. It is called as a chemical change. Now if you go for the other reaction, like methane, a gas, when reacts with another gas like oxygen, a new component is obtained, that is carbon dioxide and water. See or look at this example. In terms of simple color variations, a pink color solution when reacts with a green color solution, now you observe the changes which are taking place over here. The pink color solution, when it is reacting with a green color solution, it is getting converted to a purple color solution. Now the change which is observed here with respect to the color is a physical change. Now there is no component which is obtained from this is a physical change. In a chemical change, new components are obtained. In a physical change, no new component is obtained. Now let us take example of some new substances like sodium sulfate when reacts with barium chloride. The reaction is taking place between the two. A new component is obtained, giving rise to sodium chloride plus barium sulfate. Now because the barium sulfate is insoluble, it is giving rise to a substance which is called as precipitate. A chemical reaction, in terms of theory, if I say, you can say directly sodium sulfate reacts with barium chloride giving rise to sodium chloride plus barium sulfate. Now see here, this is a lengthy process. I am saying sodium sulfate reacts with barium chloride to give rise to sodium chloride and barium sulfate. But writing in this manner, it is a lengthy process consuming much time. You cannot understand how many atoms of sodium are participating, or how many atoms of sulfate is participating, or how many atoms of barium are participating over here. Now that is why, to give you a clear information, these reactions have to be written in mathematical expression. Like I have written over here, sodium sulfate reacts with barium chloride to give rise to barium sulfate plus sodium chloride. Now see here, from this equation it is clear that one atom of barium, why? Because nothing is there in presence or nearby the barium. So one barium atom reacts with one sulfur atom and 4 oxygen atoms, giving rise to barium sulfate. It is saving your time and giving you a complete picture of the reaction, how the reaction is taking place. That is, how many atoms of barium, how many atoms of sulfur and how many atoms of oxygen are present in this reaction. When it is reacting with sodium chloride, it is giving rise to a new component called as barium sulfate. Now, the next question is, you may ask me, what is this chemical reaction? A chemical reaction is a substance, that is, when a component, one component reacts with the second component, 2 or more components, it gives rise to a new substance. The substance which is participating in a chemical reaction, it is called as reactant, and those which is the result of the chemical reaction, it is called as product. The chemical reaction, it is represented in the form of an arrow. That is, those components which are starting the chemical reaction, they are written towards the left hand side of the reaction. They are called as reactants. If more than one reactant is participating, they are written by means of side by side, putting an addition mark or a plus sign in between. Similarly, when a product is obtained, to one product, it gives rise directly, you can write as in the same manner. If 2 products are obtained or more products are obtained, keep a plus sign in between. Left side of the equation is reactant and the right hand side of the equation present is the product which is obtained due to the chemical reaction taking place between the 2 components. Now let us go for the equations of the reactants and the products which are given. The reactants and products are separated by means of an arrow. During the course of a chemical reaction, like you take example of hydrogen reacts with oxygen to give rise to water molecule. Now, one molecule of hydrogen means 2 atoms of hydrogen reacts with one molecule of oxygen, that is 2 atoms of oxygen, giving rise to one water molecule. Okay, so here hydrogen is a gas right here at the base, oxygen is a gas right at the base, but the component which is obtained over here is a liquid, a colorless liquid. Now let us take another example. When this calcium oxide, which is called as quicklime, is dissolved in water, it is giving rise to a colorless solution called as calcium hydroxide, which is insoluble in water. That is why it is obtained in the form of precipitate. Precipitate is a substance which is insoluble in water or any solvent. Now, what we have observed over here is calcium oxide, that is quicklime, when it is dissolved in water, it is giving rise to calcium hydroxide. This calcium hydroxide solution, which is insoluble in water, is called as the component or the substance which is used for the whitewash purposes. Now look here. Calcium oxide, a solid, water, a liquid, giving rise to a solution which is semi-solid in nature, or a precipitate is obtained in this. Now when this calcium oxide is dissolved in water, it is emitting some amount of heat energy. Therefore, this reaction is called as an exothermic reaction. Exothermic reactions are those reactions where the amount of heat energy is released by the substance when it is dissolved in the solvent. And endothermic reactions are those reactions which is being completed with the absorption of heat energy. Like you take example of boiling of milk. To boil milk, you have to supply heat energy in the form of flame. So when flame is added, means the reaction is taking place with the taking in or consumption of heat energy. Such reactions are called as endothermic reactions. So based on the heat observed or released, chemical reactions are divided into two types. One is an endothermic reaction, the other one is an exothermic reaction. Endothermic reactions are the reactions which are taking place with the liberation absorption of heat energy. Like you take example of cooking of food. Cooking of food is an example of endothermic reaction. Endo in the sense taking in or consuming. Therm means the temperature or the heat, and the reaction. Now, calcium, cooking of food is an example, simple example of endothermic reaction, and the reaction between calcium oxide, that is quicklime, and water, which is releasing the heat energy or liberating the heat energy, it is an exothermic reaction. Exo means moving out. Therm means the temperature or the heat. Means the chemical reactions which involve the liberation of heat energy. Such a kind of reactions are called as exothermic reactions. Till now we have discussed about the chemical reactions, how they are changing. Means how a reactant is getting converted to a product. Now let us see the changes or the chemical reaction taking place in terms of a chemical equation. A chemical equation is a mathematical representation of a chemical reaction. Now let us take an example of the equation or the reaction between calcium carbonate and giving rise to calcium oxide and carbon dioxide. Now suppose if I am writing the reaction of calcium carbonate which on heating gives rise to calcium oxide and carbon dioxide. From this you are just getting the information that a reaction is taking place when calcium carbonate is heated, giving rise to a new product, that is calcium oxide and carbon dioxide. Now, you are unable to design or determine that when a calcium carbonate is heated, how many moles or atoms or the molecules of calcium oxide is obtained, or how many molecules of carbon dioxide is obtained. So, this can be very best explained by means of a mathematical equation or the representation which is called as a chemical equation. Now, from this equation, we can say that one atom of calcium, one atom of carbon and 3 atoms of oxygen comprises calcium carbonate. This on heating gives rise to 1 molecule of calcium oxide plus 1 molecule of carbon dioxide. Now see here, at the base of oxygen 3 is present, which indicates that 3 atoms of oxygen are participating, 1 carbon atom, because nothing, no subscript is given over here, so 1 carbon atom is present and 1 calcium atom is present. And nothing is there in presence or in front of the calcium carbonate. Ante coefficient means the coefficient is 1 over here, which on heating gives rise to 1 mole of calcium oxide. Why 1 mole of calcium oxide? Because nothing is present in front of the calcium oxide. The coefficient is 1. And 1 mole of carbon dioxide means the coefficient is 1. So the overall reaction is calcium carbonate on heating gives rise to calcium oxide and carbon dioxide. The reactants and the products are separated by means of an arrow. The head part of the arrow represents the product or facing towards the product, and the tail part of the arrow facing towards the reactant. At the base of the calcium carbonate or the reactant, I have written S in the bracket. which represents it is a solid. And here at the base I have written G, which indicates a gas. Means in a chemical equation, if there is a difference in the physical state of the reactant or product, then you have to specify it in the form of alphabets which is written at the subscript in the form of symbol. Then the upward arrow sign represents that the gas is obtained which is being evaporated or liberated. Now let us go for the second equation. Hydrogen reacts with oxygen to give rise to water. So hydrogen reacts with oxygen. Here I have written G, which indicates it is a gas, gives rise to water. L at the base or subscript I have written, which indicates it is a liquid. Next, sodium chloride on reacting with barium sulfate gives rise to sodium sulfate and barium sulfate and sodium chloride. So the equation is NaCl, means 1 mole of sodium chloride reacts with 1 mole of barium sulfate to give rise to 1 mole of sodium sulfate and 1 mole of barium chloride. Here I have written the downward arrow. The downward arrow represents that barium chloride is obtained in the form of insoluble solid, which is insoluble in water, that is, it is obtained in the form of precipitate. Now let us learn how to balance a chemical equation. According to the law of conservation of mass or energy or mass can neither be created nor it can be destroyed, but it can be converted into other form. Let us take the example of reaction between hydrogen and oxygen giving rise to water. Now, in the reaction between hydrogen and oxygen, hydrogen reacts with oxygen atom to give rise to water molecule. The substance is new. The component or the product which is obtained over here is a new product without destroying the hydrogen and oxygen. This is according to the law of conservation of mass. Now let us learn what is a balanced chemical equation. A balanced chemical equation is an equation which tells about the number of atoms present towards the chemical reaction. Is it same towards the product side? That is, the number of atoms participating in a chemical reaction, that is the reactants, is equal to the number of atoms present towards the product side. If the same two are same, then such a chemical reaction is called as a balanced chemical equation or balanced chemical reaction. Now let us take the example of reaction between hydrogen and oxygen. When you are balancing the oxygen reaction, the very first step is write down the skeletal equation. Means hydrogen reacts with oxygen to give rise to water molecule. Here we are not representing anything about the number of atoms towards the reactant side or the number of product side. Next step is balancing of the hydrogen atoms. Here we have seen that in the reactant side the number of hydrogen atoms are 2 and the number of hydrogen atoms towards the product side is 2. Means hydrogens got balanced. Now coming with respect to the oxygen atom, 2 oxygen atoms are present in the reactant side, but 1 oxygen atom is present towards the product side. Means the equation is not balanced. So first balance the hydrogen atoms. When you take 2 in or keep 2 in front of the hydrogen molecule, it becomes 2H2O. Then the hydrogens got balanced. Then going for the oxygen atom, O2, that is 2 atoms of oxygen atom are present towards the reactant side. If you look at the product side, 2 oxygen atoms are present. Now hydrogens got balanced, oxygen got balanced, which indicates the balanced equation. Means the equation is balanced now. Now let us you can write this equation as 2H2 plus O2 gives